Let's take a look at if we have dy over dx equals to y squared plus y divided by x squared plus x. Is it separable? Simple algebra. Dy divided by y squared plus y equals to dx divided by x squared plus x. So obviously it is separable. Now let us move on to check to see if it's linear or not. So if y is a function of x, we need to have the definition, and this differential equation must satisfy that definition, which is a1x y prime a sub 0 x y equals to q of x. So let's take a look at this. We have y prime, and on the other side, if we just separate this fraction, you get 1 over x squared plus x times y squared, the red flag, plus 1 over x squared plus x times y. Well, as you remember, in the definition of a linear differential equation, we cannot have the exponent other than 1 or 0 for your y. So it's not linear if y is a function of x. What if you write x as a function of y? X equals to, for example, g of y. Again, if you flip these, then you end up with x squared on the numerator. X squared makes it not be linear. So it doesn't matter if you write y in terms of x or x in terms of y, it's not going to be linear. So far it's just separable. Let's check to see if it's exact or not. To be exact, we need to have the definition satisfied. First, write it in differential form, then check to see if the partial derivative of m with respect to y is equal to partial derivative of n with respect to x. Well, here you have dx times y squared plus y minus x squared plus x dy equal to 0. With respect to y, you get 2y plus 1. With respect to x, you get negative 2x plus 1. Obviously, they are not equal to each other. So if this guy is not exact, you might be interested in saying, hey, can I use substitution eventually? It means that do I have a homogeneous differential equation? To check to see if it's homogeneous, we need to check to see if m and n in differential form are homogeneous functions or not. So let's just write it the way that we see it in differential form. Minus x squared plus x dy equal to 0. So this is our m, this is our n with a negative sign in front of it. If it's homogeneous, these two functions must be homogeneous of the same degree. Very well. You could see that, hey, you have y squared and here you have y, so you cannot factor out the appropriate t to isolate y squared plus y on one side. Let's take a look at this in detail. Tx and ty becomes, so since we don't have any x here, we just substitute ty for y. We get t squared y squared plus ty, which cannot be written in terms of t to alpha, y squared plus y. So there is no way m is homogeneous function. So m is not homogeneous function. So ODE is not homogeneous.